Hi everybody, today's video we're going to be talking about the periodic trends. So what are the periodic trends? Ionization energy, electron affinity, electronegativity, atomic radius, ionic radius, and lastly metallic character or non-metallic character. We're going to first start by talking about ionization energy. Ionization energy is the minimum amount of energy needed to remove a valence electron from a neutral atom or molecule. And the order of increasing ionization energy goes from bottom to top and from left to right. So we're going to go over a couple examples with that. So which element has a higher ionization energy? Is it hafnium or copper? Our first step here is to locate both hafnium and copper on the periodic table. Hafnium is located all the way down here as number 72, and copper is located all the way up here, number 29. And we know that our periodic trend for ionization energy goes from bottom to top and from left to right. So that's going to mean copper has a higher ionization energy because it is not only on top of hafnium, but it's also to the right of hafnium. Our next example states which element has lower ionization energy. Is it going to be barium located down here, or is it going to be phosphorus located up here? So we know our periodic trend increases from bottom to top and from left to right, which means that it decreases from right to left and from top to bottom, which means that barium is going to have a lower ionization energy. Next we have electron affinity, and electron affinity is the likelihood of a neutral atom to acquire an electron and to form a negative ion or an anion. So the increasing order for electron affinity is from bottom to top, and from left to right, just like our ionization energy that we just talked about. So which element has a higher electron affinity? Is it going to be cesium, located at number 55, or is it going to be krypton, located number 36? Since electron affinity is going to increase from bottom to top and from left to right, we know that krypton has a higher electron affinity. And which element has a lower electron affinity? Is it francium, located down here, number 87, or is it radon, located over here, number 86? We know that electron affinity increases from bottom to top and from left to right, which means that it decreases from right to left and from top to bottom. And because francium is located to the left of radon and below radon, that means that francium is going to have a lower electron affinity. Next, we're going to talk about electronegativity. Electronegativity is the measure of likelihood of an atom to attract a bonding pair of electrons. And it's also important that you note that fluorine up here on the periodic table has the most electronegative element with a value of 4.0 on the Pauling scale. And the Pauling scale is just what we use to measure the electronegativity of the elements. So the increasing order for electronegativity is from bottom to top and from left to right, just like the last two periodic trends. Which element has a higher electronegativity? Is it going to be oxygen, number 8, or is it going to be fluorine, number 9? So electronegativity increases from bottom to top and from left to right, which means that fluorine is going to have the higher electronegativity. And if you remember on the last slide, I said that fluorine is the most electronegative, so you should have been able to figure that out without drawing out your trend. And which element has a lower electronegativity? Is it going to be potassium, number 19, or is it going to be carbon, number 6. Well, if electronegativity increases this way, that means it's going to decrease from right to left and from top to bottom. And because potassium is not only to the left of carbon, but it's also lower than carbon, that means potassium is going to be our answer. Next, we have atomic radius, and atomic radius of a chemical element is the measure of the size of its atoms. And another way you can think about this is the distance from the center of the nucleus to a boundary of the surrounding cloud of electrons. And atomic radius is going to increase from right to left and from top to bottom. So it's kind of the complete opposite of the last 3 periodic trends. Which element has a greater atomic radius? Is it silver or is it sulfur? Well, since atomic radius increases from right to left and from top to bottom, that's going to mean our silver is going to have a greater atomic radius. And which element has a smaller atomic radius? Is it going to be aluminum, number 13, or is it going to be gallium, number 31? Since atomic radius increases this way, that means it's going to decrease from bottom to top and from left to right. And because aluminum is on top of gallium, that means aluminum has a smaller atomic radius. Now we have ionic radius, and ionic radius is the radius of a given atom's ion in an ionic crystal structure. And a lot of people like to think about this in terms of atomic radius, which, like we said on the last slide, increase from right to left and from top to bottom. But I've also included a diagram here of the periodic table, and it shows you the ionic radius relative to the other elements. So which element has a greater ionic radius? Is it going to be chlorine, which is located up here as number 17, or is it going to be astatine, which is located all the way down here, number 85? Well, we know that ionic radius increases this way, so that's going to tell us our astatine has a greater ionic radius. But of course we would like to check that, so we're going to go over to this diagram over here and locate chlorine and astatine, and based on the relative sizes on the diagram, we can see that astatine number 85 is going to have a greater ionic radius than chlorine number 17. Now, which element has a smaller ionic radius? Is it going to be rubidium or is it going to be strontium? Rubidium is over here, 37, and strontium is 38. And since it increases this way, that means it's going to decrease this way. And because strontium is to the right of rubidium, that's going to mean that strontium is going to have a smaller ionic radius. And to double check this, we're going to use our special chart over here, which is going to show rubidium here and strontium here. And rubidium is bigger, strontium is smaller, so that just double checks our logic. Our last trend to talk about is metallic character and non-metallic character. So metallic character refers to the level of reactivity of a metal, and metallic character is going to increase from right to left and from top to bottom. And we also have non-metallic character, which you're likely to be asked about, and non-metallic character is going to increase from bottom to top and from left to right. They are complete opposites of each other, obviously because metallic and non-metallic are opposites of each other. So which element is more metallic? Is it nickel or is it titanium? And we know that our increasing order of this trend is from right to left and from bottom to top, and because titanium is to the left of nickel, we know that titanium is more metallic. Now our next question asks us about which element is the least metallic. Is it going to be radium, which is located all the way down here, or is it going to be zinc, which is located all the way up here? So we're going to draw out our trend for non-metallic or least metallic, and that's going to go from the bottom to the top and from the left to the right. And because zinc is on top of and to the right of radium, we know that zinc is the less metallic of the two.